Welcome everyone. Thank you for joining this webinar about customer reports. My name is Kimkes and I am a product specialist at Viedoc, and I will be the main presenter. My colleague Johannes Molin will be monitoring your questions and we will answer them together at the end. So the plan for this webinar is to first go through some PowerPoint slides. And with these slides, I will introduce reports and R. And that will take about 10 minutes. After that, there will be a 20-minute demonstration during which I will show how to write a small custom report in R. And the last 10 to 15 minutes are reserved for questions and answers. Some general information. We are recording this webinar and we will share the recording with you later. If you have any technical issues, then please ask for help in the chat and one of my colleagues will try to assist you. And if you have any questions about custom reports, anything that you would like us to address during the Q&A session, please ask that in the Q&A box. So, Viedoc Reports. I assume that most of you are familiar with this, at least to some extent. It is included in every study license, so you can use it without any additional costs. It contains 5 different tabs: the dashboard, demographics, adverse events, data browse, and reports. And these contain lots of useful metrics and statistics. And the one that we are going to focus on today is the reports tab. So on the reports tab, you will find a list of standard reports. And these are provided by Viedoc and they are present in all studies and you cannot customize them. You can add to this list with your own custom reports. So for this, you have to write an R script and upload that to Viedoc. And the output of your R script will then be shown as a custom report. These can be customized for each study, or you can write your script in such a way that you can reuse it in different studies. The visibility can be set for each role. These custom reports, they can be tables or they can be plots. So briefly, how do these custom reports work? So for every study that has reports enabled, the system will perform a daily data export for every role that has access to reports. And this data export will be made available to your R script. So in the illustration on the right, you will see the database, and from that, 3 different exports are made in this example. One for the investigator, one for the monitor, and one for the data manager. And this happens on a 24-hour schedule. The exported data, for example, for the data manager, it's the red data set that is specific for this role and contains only the data that the data manager is allowed to see. So you do not need to write different R scripts for each role if you have any data that should be hidden to this role. That's handled by the system. So if the data manager loads up the custom report, then the specific data set for the data manager will be used, and that will be sent to an isolated environment that runs your R script. So why is it important that this is an isolated environment? This R script will be having access only to your data export and not directly to the database. So that means that you cannot do anything wrong and by that make by accident an edit to the production database. It's entirely safe to experiment. Another important consequence of this is that your data can be up to 24 hours delayed. So if you add a new patient today, then that patient will show up in reports tomorrow. So that's something that you should be aware of. So this shows one example of a custom report. This is a survival curve according to the Kaplan-Meier model, showing the survival rate with confidence intervals. If this is something that you would like to use in your study, you can find the code for this on the e-learning. Another example of what you could potentially do with custom reports is to combine data from multiple forms. So the example shown here has a few data points from the AE form combined with a few data points from the DM form. Also for this report, there is example code available on the e-learning. So the question is, how do you write these R scripts? And that's the main topic for this webinar. So first of all, you would need to have R installed on your computer. And probably the best thing to do is to install RStudio, because that's a nice piece of software to work with R. So R is a programming language. It's used for data analysis and statistics, and it is very widely used. So that means that if you ever get stuck, then you can contact our support, of course, but you can also search online, and most likely you will find the solution to your problem there. R by itself has quite a lot of functionality, but it can be further extended with packages. I show a few examples here on this slide. The first one, dplyr, is provides some functions for data transformations, and that is one that is very generally used, can be used in pretty much every project. The survival package, for example, is much more specific, and that one was used to construct the survival curve that I just showed. So if you have R installed on your machine, then you still need to have some data to work with. The data can be obtained from Viedoc Reports. From the settings menu, there's a download button. This downloads a zip file, which contains a number of files. The one that you will probably be working with the most is the EDC data. That is the data from clinic, so the CRF data, queries, medical coding. It's only a sample of the data, only the first few subjects. Then there is also data from admin, some data from designer, and a file called utility functions. And the utility functions provides a couple of functions that are provided by Viedoc and that help with displaying of your data. It's optional to use those. So if you have R installed and you have downloaded some data to work with, then it is good to have some examples how to write custom reports. And we have recently added an e-learning page that shows a couple of custom reports. So on this e-learning page, there are 8 different examples. And you can read a short description about them and download the code. And then you can adapt this code to your own study, or even if it's not applicable at all to your study, you can see it as some training material. We are planning to still add more to this e-learning page. And one report that we are currently planning is an E2B report template. Okay, so let's now switch to RStudio, and then we can write a short report there together. Okay, so now I am in RStudio, and you can see that it consists of 4 different sections. On the top left, there is the place where you write your script. I already wrote 2 lines of code to load the packages that I will be using. On the bottom left is the console. Here you can write some code for some testing purposes, some code that will not become part of your script. So 1 + 1, 2, or x equals 1. On the top right, you can see the different variables that exist in your environment. In this case, you can see that there is a variable called x with a value of 1, which I have just created. And in the bottom right, you can find some help, and I will talk about that one more later. Before starting to write our small custom report, I just want to cover a few R-specific things. So I just created a variable called x with a value of 1. The way I did that is perfectly fine in R, but the more R-specific way to do this is to have x, arrow to the left, 1. It does the same thing, but it's more common to write it like that in R. I can also assign multiple values to x. That I do with C and then the values between brackets. I can calculate the mean of x. And I can also round that to 1 decimal place, for example. For that, I would first need to assign x, the mean of x, to another variable. Then round that variable to 1 decimal place. That's how you would do it in most programming languages. But in R, it's actually more common to do this a bit differently, and that is by using a pipeline. So we start with x, and then we use the pipe operator. That's percentage greater than percentage. You will use that one a lot in R. Then the function that we want to use, so mean, and another pipe operator, and the next function that we want to use. So what this does, it takes the first value and it uses it as the first input for the next function. Then it calculates this and it uses it as the first input for the next function. So this is very common to work like this in R. Okay, now let's load the EDC data. I downloaded that beforehand from Viedoc Reports, and I just double-click the file. Now it's loaded. So you can see in the top right that this data now exists, EDC data, and I can click on it and explore the data. So EDC data, you can see it's a list of length 10. So it has 10 different elements in this list. The first one is called event dates. And you can see it's a data frame with 46 rows and 21 columns. And I can press on this small icon here to show that data. Then you can see a data frame is basically just a table. It has numbered rows and it has named columns. And this looks a lot like an Excel export from Viedoc. It's pretty much the same. So we have a number of data frames, and we also have another list, and that one is called forms. I can expand that one, and you can see the different form IDs. So DM, the demographics form, VS, the vital signs form. And these are in turn also data frames, so also tables with data. So if we are now interested in the demographics data, for example, then that is located in the EDC data forms DM. So let's make a new variable in our script, DM, and it was EDC data forms DM. Use a $ in between. Okay, so this has now created a new variable. You can click the run button or you can use Control Enter. So it has created this new variable, dm. I can click it and you can see the data. There's a lot of columns. I don't need all of those columns, so I will now select only those that I need. So for that, I will use the pipe operator and then the select function. Then I will select only the subject ID and the site name and the age. Control Enter. And you can see now we have a table with one row per subject. Columns are the subject ID, the site name, and the age. If I want to know more about this select function, I can click on it and press the F1 button on my keyboard. And then in the bottom right, I get some explanation. So the select function, it keeps or drops columns using their name. I can scroll a bit through that. So you can provide the name explicitly as I have done, but you can also use certain patterns. So select variables that match a pattern, for example, those that start with a certain character or with a certain word, that end with a certain word. Okay, so I now have some demographics data. I also want to have adverse events data. So this is very similar. It's in EDC data forms. Okay. Let's see how that looks. So, okay, this is also just a table with the data. And this has one row for every AE. We can see that for subject 101,001, there are 2 rows, so there are 2 AEs reported for this subject. And I want to get the number of AEs for each subject. So to do that, I will group this data by subject. Group by subject ID. Then I will summarize it. One called AE count, that is N. What is N? That's F1. Gives information about the current group, and it shows here N gives the current group size. So that's the number of rows within each group. So the output. So we have now column subject ID, and we have the AE count, the number of AEs for each subject. I can copy this code because I'm going to do something very similar for the SAEs. So for the SAEs, the serious adverse events, I also start with the data from the AE form, but I don't want to count now all the rows. I only want to have those rows where it was answered that this event was serious. So I will have to filter my data, use the filter function. And then I will have the condition AE ser. That's the item ID given to the radio button item in the design. Is yes. Okay. I can add actually even more columns to this because I also want to have the terms of the serious adverse events. So for that, I am going to use the paste function, which combines text data. So paste AE term. So I want all the AE terms for each subject within the group. And that data, I will collapse it to one string separated by commas and a space. From this, I can show you the output. Now I have for the SAEs, the subject ID, the SAE count, and the SAE terms. And you see for the first subject, there is there are two SAEs, and the terms, they are indeed separated by a comma and a space. Okay, so now I have created three small data frames. One for the demographics data, one for the number of AEs, and one for the number and terms of the SAEs. And I want to combine that together. I will create a new variable called combined and start with the DM data. I will left join the AE data. Left join keeps all the data in the first input, the DM, and only the matching data in the second input, the AE. I also have to specify how I will join this data. So both of these data frames have the subject ID. So that's how I can match them. So by subject ID, I will select this line, copy it, because I have to do exactly the same for the SAE data. I can run this, and you see now I have here my combined data. So I have now a table with one row per subject. The columns are the subject ID, the site name, the age, the AE count, the SAE count, and the SAE terms. So this is already starting to look like a small report. You might notice that there are quite some missing values. Those are NA, that means not available. For subject 2, the age is not available. And that one is actually missing in the EDC. It was not entered. But for the columns AE count and SAE count, there are also some missing data. And those are for subjects that don't have any AEs reported. So actually, this shouldn't say not available. It should say 0, because the count is 0 if there are no AEs. So I want to replace the NAs in these two columns with zeros. Okay, so for that, I will mutate. What is mutate? I can select it, press F1. Mutate is a function that you use if you are going to create, modify, or delete columns. So I want to modify a column. So I will mutate, and I will assign it to the column AE count. I will overwrite the data that's already in there. AE count is, okay, we're going to replace NA. That's what we wanted to do. That's a function that's part of the dplyr, of the tidyr package, sorry. Okay, AE count 0. So I'm going to replace NAs in AE count with 0. And I will copy this line because I want to do exactly the same for the SAE count. Okay, so let's see what the output looks like now. So now these NA values from these two columns are gone. They are replaced with zeros. Okay, so the next step, I want to prepare my data for display using the utility function. So, or maybe I should show one more time the output and show why I want to do that actually. So if I want to filter my data, there's here a button called filter, and you can also filter in Viedoc Reports. That works in a similar way. So if I click on filter and I want to filter for the site name, I can type here with free text. So if I want only the data for site number 2, I can type here 2, and that works. But what I really want is to have a drop-down menu, because I have only 2 options, and will be easier to pick from a drop-down. And that's something that the prepare data for display function takes care of. So let's run that. and I got an error that this function cannot be found. And that is because in Viedoc Reports, this function is already loaded. But if you are working offline in RStudio, then this function is not known. But it is part of the downloaded file utility functions. So I can open that file, I can double click it. Then while it is open, I just click on the source button. Now these functions have appeared in my environment. I can close this file again. Now this function is known. Okay. Show it one more time. I can also show the filter option. Now I have a drop-down. You will also have this drop-down now in Viedoc Reports. Okay, so now the last thing that I want to fix with this small report is the column names, because they are not very consistent, not looking very nice. It's just the variable names. So for that, there is the utility function set a label. Labels is a list. And then I just provide for every column what I want to show up. So subject ID, site name, one is the age, number of AEs, number of SAEs, and the final one was the SAE terms. Now you see that in the headers, there are now 2 rows in the headers. So the second one is what I just typed. Those are the labels, and those will show up in Viedoc Reports. So the last thing to do is to create the report output. Your final output of the script must be called report output, otherwise you will get an error. That has to be a list. And then I can provide a name. This name will only show up if you have multiple sub-reports within your report. Demo is list. And then I have to say the data is combined. Combined is the variable name of the data. And that's all. Now I have created a report. Before uploading this to Viedoc Reports, I have to remove the first 2 lines here because the packages are already loaded in Viedoc Reports, and it's not allowed to say that you are loading packages. These lines must be removed. You can type a hashtag in front to make them a comment. That's fine. Or you can just delete them completely. Let's see. Okay, so I have a few minutes left. So let's go one step further here. We have now 1 report that shows 1 row per subject, but I can easily add also a summary per site. So let's make another small report by site. I will start with the report that we already have, that is per subject. I will group this by site name. And then summarize the data. And then I can have, for example, subject count is n. So the number of rows, it's 1 row per subject. So the number of rows within each group, the group is the site. Okay. I could also add here, for example, the age of the oldest subject. So oldest is the maximum of age. And I can also add the total number of SAEs at this site. That would be then the sum of the SAE count. Let's see how that looks. Created this new variable called by site. I will open it. Now you see that I have one row per site. The first column is the site name, and I have the subject count. Then I have the age of the oldest subject and the total number of SAEs. And you can see there is missing data for the first site for the oldest subject. And why is that? Well, one subject did not have an age. So let's look at the max function. Okay, in the documentation, it says that there are a few different arguments possible, and one of them is called na.rm, and that indicates whether missing values should be removed. And I can see here that the default value is false. So missing values are not removed before we calculate the maximum. And we want to remove them, they should be ignored. So I can add this option, na.rm is true. So now these missing values will be ignored when calculating the maximum. If I open again the output, now you see that maximum age is calculated correctly. So to add this one also to the report output, just type here a comma and I add a second line. Now I add my second sub report and I call it by site. That will be a list also, and the data is a variable by site. Because I now have two sub reports, these names are going to show up in reports. So maybe I want to replace this first one called demo now by subject. Okay, so now I have created a report that contains two sub-reports. Okay, and that's everything that I wanted to show during this demonstration. So let's go for the Q&A session.
Thank you, Tom, for an excellent presentation. I have been monitoring the Q&A here, and we have a few questions in the chat. The first thing I see some people are being a little bit nervous about or cautious about is the visibility. Who can see what in Viedoc reports in general, and also for the specific reports. Could you perhaps go to Designer and show how the visibility is set for the
Yes, of course. I will share my screen again. Okay, so I am now logged into Viedoc and I will go to Designer and to my custom reports demo study. I go to the global design settings, the reports configuration, and then to the visibility settings. And here you have the 5 different main tabs that are shown in reports: the dashboard, demographics, adverse events, the data browser, and reports. And I can say for each one of them which roles should have access. In this case, only a few of them are selected and only the data manager is allowed to see it. I could add more different roles to it as well. Besides needing to be selected here, the role also needs to have reports permission in the study design. So it has to be set in 2 places, in the study design itself and in the global design settings. Then for custom reports specifically, there is custom reports setting, and I can now edit one that I added before. And you can set up for each single custom report which roles should have access to it. So in this case, also only the data manager is selected, and it's the only role that can see the survival curve. And you can even select if the data manager is allowed to see it in training and/or production mode. Then, in addition to this, as I illustrated before, the custom reports are generated based on a data export. And this data export is also role specific. So if your custom report contains any data points that are hidden to a certain role, then even if you give this role access to that custom report, that data point is not going to show up because it won't be part of the export.
Excellent. Thank you, Tom. Then we have a few questions on different R packages used, and I can probably answer the first one. There is a question: if a customer has a request or wants to use an R package that is currently not supported in Viedoc Reports, what should they do? And the easy answer is reach out to support. We would be happy to discuss that, and we'll take your suggestions, listen to your use cases and so on, and then evaluate if that's something we can add to the platform. So please feel free to reach out if you have suggestions on that. Next question on R packages, and I'm going to direct this to you, Tom, because I don't know the answer, and I don't mean to put you on the spot. Do we have any information of the R packages that are supported today?
Yes, we do. This is actually not shown in the e-learning at the moment, but if you download from Viedoc Reports, from the settings menu, the sample data set for custom reports, then this will contain a file that is called sample report code. And I have opened it now, but I think I'm not sharing my screen. So let's do that. Okay, so this is a sample script that is included in the data downloaded from Viedoc Reports. And it shows here all the different packages that are currently supported in reports. So it is this list of packages that you can use.
Excellent. Thank you, Tom. There were also a few questions when you showed the template reports that we have in the e-learning, and they asked about specific details on the reports. Perhaps you could go to that page and go through, quickly just explain each report.
Yes, of course. Let's zoom in a little bit. Okay, so this is the e-learning page with the different example custom reports. And currently we have 8 of them. So the first one is an ongoing AE report. This shows all the AEs in your study where it was answered that the AE is ongoing. And it has a separate sub-report that highlights those AEs that have been ongoing for 30 days or longer. Then there is a treatment-related SAE report. It shows all the SAEs in your study where it has been entered that it is probably or certainly related to the treatment. Then there is a serious adverse events combined with demographics report. This is an example of how to combine data from different forms. So you can have a look and do something similar. Then there is an outliers report. In the example, this uses the blood pressure data. Of course, you can adapt that to any other variable within your study. Our example is for the blood pressure, and it shows those data points that are statistical outliers. I believe it is more than 2 standard deviations from the mean. There is a drug accountability report. This uses the kit number from the kit allocation form and from the kit return form. And it determines the number of days in between those two visits and how many tablets should have been used in those days, and the discrepancy between how many should have been used and how many were actually used. So that can also be a useful report if you can adapt that to your own study. There is a medication inconsistency report. This compares the CM forms, the concomitant medication, with the AE forms. And it looks for discrepancies where you say on the CM form that this medication was prescribed because of a certain AE, but on the form for this AE, it was entered that actually no medication was prescribed because of this AE, and vice versa. There is a blood pressure plot. This is an example of a relatively simple plot and how you can make that in R, because most of the examples so far, they have been tables, but you can use plots as well with the plotly package. And finally, this one I showed before, it's the survival curve. So this is a little bit more advanced. So this one, you can adapt it as well to your own study. It uses the survival package and the Kaplan-Meier function to make this plot in the plotly package.
Perfect. Thank you, Tom. And I can perhaps add that just like with the R packages, if you have suggestions on new template reports, feel free to reach out to us and make suggestions, and we will consider adding additional templates to our e-learning as well. I think there is perhaps time for one last question, and this is a question we get from time to time, and also today. It's about the 24-hour sync. What if the customer needs to look at fresh data in Viedoc? What can they do? Or in Viedoc Reports, what can they do?
Yes, so that is something that is possible. I will again share my screen. And now I will go to my demo study and I will load up Viedoc Reports. That will take a few seconds. So normally your production data syncs every 24 hours. And you cannot set that up to be a different interval in your specific study. It will always be 24 hours. But you can synchronize the data manually. So for that, you scroll down to the very bottom of the page, and it's a little bit hidden because it doesn't show clearly that it is a button, but in fact, you can click this text at the very bottom called data snapshot from, and then the date and time. If you click that, it will give you a message that an on-demand data sync job has been submitted. Now you have to wait a few seconds until this is completed, because now in the background, a data export is running. That might take a little while. It shows now that it is done. It gives me a reload button. That takes a few seconds. And now I have the most up-to-date data in reports.
Excellent. Thank you, Tom, for an excellent presentation and good answers to all the questions as well. So we will send out a link to the video so you can watch it afterwards as well as the questions and answers that we have received during this webinar and the webinar earlier this morning. Thank you very much for joining, everyone, and have a good rest of the day.
Thank you. Bye.